Alright folks, so welcome to the unofficial part 2 of the video. My apologies, I just realized I may have just had the sound off for the first one, so my apologies here. So here's what we have with simplifying for the triangle inequality exploration. So as you can see, again, you have these forms here for yes, no, and what we're getting at here, in essence, without my voice obviously, and hopefully maybe some of you had the close credits, catching on. In this case, what we're saying is the small and the medium, the sum of them together has to be greater than the large side. So what we're basically kind of saying is, again, when we have those values, they all have to be, again, added together in order to do so. And this makes a triangle then. Now, we're adding this to the principal idea of saying, okay, now using the tool, can we investigate this idea when we find these values? So what I was doing is I was basically kind of playing around, and I was saying, okay, 5 and 12, obviously, what is the possible greatest side length that they can share in this case? So if I look, what I'm doing is I'm going to go ahead and add these values all the way to 16. And the reason why is because anything over that value, so in this case I make it 16, this is going to make me the largest possible length of the triangle. And as you're going to notice, when I use it, makes me that triangle, get close, a little bit back ways, but in this case, again, that's going to make me my triangle. There we go, perfect. So what you're going to ask yourself then is, well, why? Well, again, if we're looking at, again, the value with that idea, back to our thing here, the reason why is because if we have the longest side, if I add the values together, like I was saying, okay, 5 and 12, assuming that they, again, are the small side lengths, obviously that's going to end up giving me the value of 17. Now, what we were saying is, okay, well, with that in mind, what we need to do is we need to go ahead and find that shortest side length, which in this case we know is 16, because any value has to be less than 16. Or it has to be less than 17. Then the sum of 17. And again, that makes sense because in this case, again, any value that's less than that is going to work. In this case, if it's equal to 17, obviously it's not going to work. So again, if I'm putting it there, it has to be less than 17. Now, what is the shortest possible side length? Well, again, if we go back and explore this a little bit, what you're going to notice is if I take this value all the way down, and I'm going to take it down to the value of 8 here, that value 8, again, I have my B value, and I have this one. Go ahead and kind of move it around just a tad here. What you're going to notice is this one is also going to make a triangle. And right on the money. Now, with that though, I'll pop up my thing again. With that though, what you're going to notice is, again, any value that's less than that is not going to work. So in this case, what I'm going to do is I'm going to do a little subtraction here. So 12 minus 5. And the reason why is because that value is 7. So in this case, if we look, the value of 8 worked. So in this case, any value has to be greater than the difference. I'm going to abbreviate here, the difference of 7. So in other words, the value has to be greater than 7. Now, if I were to write this out as an inequality, hence the reason why we have the inequality part now, what we're going to do is we're going to write that, so any value between these, so meaning less than 17 or greater than 7, is going to make this triangle work. So that's basically what the triangle inequality formula states. As long as those values are, so we have two sides, as long as we have the sum of them and the difference of them, and the value for the third side is in between them, it is going to work as a triangle. Everything else will not work. So again, you can try it and play around with it as much as you kind of want, and that's kind of the nice thing about it. All right, and so it says the values are found from parts A and C for problems 5, with the minimum and maximum limits for the length. So again, just what we did here. It says then find the third side for the two sides, the lengths of 12 and 5. In fact, these restrictions, they also create what we call the triangle inequality. So what we're going to do is we're going to just practice here with the final 3 problems here. Again, hopefully you were able to kind of figure them out pretty quick. But with that in mind, it says determine the minimum and maximum. So the nice thing is, if we want to find the max, we're just going to add the values. So if I add ED, which is 13, and I add the value of UF, which is 19, that value, whatever it is, and I just use X there for whatever side length I'm using, so I just label it X. That value has to also be between the difference, so 19 minus 13. All right, we do a little simplifying here. 19 minus 13 gives me the value of 6. And then the value of 13 plus 19, that value is going to give me 22. So therefore, that value has to be in between those. So in other words, again, any value, and you can write this out, any value that is 21, I guess you could say 7 through 21 will work. So just keep that in mind, folks. Okay, so again, when we have these values, if you're using whole numbers specifically, those work there. All right, same thing kind of idea. We're going to go ahead and make xy the value of x. Again, you can label it xy if you want to. I'm going to go ahead and put that in the middle, and then I'm just going to find the sum, so 14 plus 15. And then we're going to do the minimum point, so 15 minus 14. And we're going to get our value. So 15 minus 14 gives me 1. And then that x value, 14 plus 29, or 15, gives me 29. So again, with that in mind, any value that's less than 29, any value that's greater than 1 will work in a triangle. And again, always can try it on the thing there. All right, and the last one is just an expression. So what we're going to do is we have big A, big B, and big C. And we got the little a and little b there. These again can stand in for any values we want. Same thing with x. So with that, I'm going to go ahead and put x there. And then I'm just going to label my parts. So in this case, if I'm looking, I have A and B. So I'm just going to go A plus B. Obviously, in this case, again, that's my greatest one. And then whatever value, assuming that A minus B or B minus A, again, we can assume whatever, again, is going to make the difference there. So therefore, I can just leave it like that because those are my values. All right, so this is triangle inequality. Again, not hard, and again, that's kind of the idea. What we wanted you to do is make sure that you understand that idea. So the small and medium added together, that sum has to be greater than that large side in order for it to make it work as a triangle. And when we're writing the inequality part of it, in this case, any value for the third length, again, the sum of them, 12 and 5 and 12, when we add them together, cannot be greater than 17, nor can it be smaller than the difference of 12 minus 5, which is 7. So just keep that in mind. All right, otherwise, hopefully, again, this video finds you well. Again, this will kind of wrap up our chapter 2. Again, we will kind of finish up talking about composition of functions. We'll kind of wrap it up a little bit with more triangle inequality talk. And then again, this I believe will be on your test, but you will not have a quiz on it, so just keep that in mind. Otherwise, have a great rest of your day, and make sure you're good for the sun. Let me know if you have any questions. Otherwise, have a great day. See you later. Bye.